And once again, our math practice standard number 6 is attend to precision. So whenever I ask you for a rule or a sentence, make sure you give me a full sentence. If I ask you for an area, make sure it's on units squared. Just be precise. Okay? Here we go. Our objective for today, I can simplify exponential expressions using the division properties of exponents. Read it together. 1, 2, 3. I can simplify exponential expressions using the division properties of exponents. So we already know we're on the same concept, right? Tell your neighbor the concept, please. Very good. Exponential expressions. We're still on the same one, and we're still simplifying. But today, we're going to start with division properties. Okay? So here we go. We know what exponential expressions are. Okay? We already covered this. We don't need this to write it down, right? You already have it. But we do need steps. Write these down, please. There's 3 basic steps. Number 1, identify the exponential expression as a quotient of powers or power of quotients. Notice here, we only have 2 properties to cover today. And basically, if I was to tell you, we're probably just going to focus on this one. This one is very similar to one that we already did. So that's why I'll leave that till the end. So identify the exponential expression as a quotient of powers or power of quotients. Identify the exponential expression as a quotient of power, power of quotient. Write that down. Identify the exponential expression as a quotient of powers or power of quotients. Identify the exponential expression as a quotient of power or power of quotients. Identify the exponential expression as a quotient of power or power of quotients. And notice the second step. It's the same as the other one, right? Use the appropriate property to compute. Same. Use the appropriate property to compute. And step 3, simplify. Once again, identify the exponential expression as a quotient of power or power of quotients. From there, use the appropriate property to compute. And number 3, simplify. Okay, here we go. So once again, first step, identify the exponential expression as a quotient of powers or power of quotients. Only 2 properties, right? And from there, once you identify it, you're going to use either property to compute and then simplify. Okay, here we go. So write this down. Underneath those steps, please. Write quotient of powers property. Quotient of powers property. Quotient of powers property. Example Q. Example Q. Here we go. Once again, I'm going to go over an example. You guys are going to pay attention. I'll have you guys talk it out to come up with a rule, and then we'll go from there. Here we go. Pens down, eyes up here. So I'm going to start writing utensils down. Here we go. I'm going to start with this. 3 to the 6th over 3 to the 4th. Okay. In the past, we did something like this, right? And I introduced something like that, and I said that becomes 3 times 3 times 3 times 3 times 3 times 3, which becomes, let's see, 3 to the 6th, and so on and so forth, and if we can multiply it out, right? However, now we have a fraction, and now we have a denominator. So therefore, my denominator, I'm going to do it in red. This becomes 3 times 3 times 3 times 3. Okay. But what do I know about division? What is 3 divided by 3? That is 1. 3 divided by 3 is 1. This is another 1 and another 1. Okay? So let's see what I have in the numerator. What is 1 times 1 times 1 times 1 times 3 times 3? That is 3 to the 2nd. Okay? What do I have in the denominator? 1 times 1 times 1 times 1, that is 1. Therefore, this becomes 3 to the 2nd. If I ask you to compute, this will be a 9. 3 times 3 is 9. Are we there so far? Now, let's see if you see the rule. Everybody look up, please. We know that this is called factored form, right? And I said, when in doubt, factor out. But we don't need to do this step if we know the property. Everybody look up. Here goes the property. See if you see what I see. Don't say it out loud. Here are these two exponents and become this. Okay? Think about your rule. I'm going to do another another example and see if your rule works. Just to clarify. X to the 10 over x to the 7. Let's see. That becomes x times 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 x over x times x times x times x times x times x times x. And what do we know that this is? 1, 1, 1, 1, 1, 1, 1. Are we there so far? So this is 1 times 1 times 1 times 1 times 1 times x times x times x. That is x to the third over 1. And this becomes x to the third. So once again, think about the rule. What happened to these to get this? Okay, talk it over with your neighbor, please. Okay. Copy that down, please. Copy that down, and then we're going to come up with our rule. Or I'm sorry, our property. So if we were to come up with a rule, let's see. Let's start off our sentence right. What operation are we doing? What did we say was today? What did we do? Everybody? Division. So therefore, when what? When dividing, what are we dividing? What are these called? What is our main concept? Exponential expressions. When dividing exponential expressions, okay, but they have what? What is the one thing that they have in common? Think about it. What do they have in common? Look at this. Look at this. What do they have in common? What is that called? Yes. Okay. Yes? What's that? Okay, but what is that called? It has a name. Yes. Okay, so when dividing exponential expressions with the same base, comma, what did we find out we do? Subtract the exponents. When dividing exponential expressions with the same base, I subtract the exponents, okay? I want you to double underline same base so that you remember that it only works when they have what? The same base. Bless you. Bless you. So, with that said, if according to the definition that rule works with exponential expressions with the same base, what if I gave you this? X to the fifth over y to the fourth. Think about it. Don't say it out loud. What would I write here? Talk it over with your neighbor. See what they think. Some of you are a little bit stumped. Let's see. Do they have the same base? No. So we can't use that property. Is it division? Yes. So the only property that we can use in this case is the quotient of powers. But since they don't have the same base, therefore, we just write it the same. It stays the same because we cannot do anything with it. So I want you to copy this and write a note for yourself. Stays the same. Write a little asterisk. Draw a little heart. Oh, so you can remember. Stays the same. Okay, let's do some practice problems. Example 1A and B. Here we go. 1A and B. Ready? Okay, here we go. Copy these down, please. 1A and B. It says simplify. 2 to the 9th power over 2 to the 7th power. B is y over y to the 4th power. And let's do these together, since we already found the rule. So look at this one. Everybody look up. Do we need to write it out in factored form? No, we already know the rule. So therefore, are they the same base? Yes, so it's a 2. What happens to the exponents? Subtract, so 9 minus 7 is 2. And if I was to ask you to compute, what is 2 to the 2nd? 4. You got it? Piece of cake? Yeah, right? All right, so look at this one. What did I ask you to do whenever you see a variable and a number without an exponent? You add a what? 1. Okay, so now, do they have the same base? Yes, so that's y. And what happens to the exponents? Subtract. So now check this out. I'm going to write it out so you guys can see how I got the answer. The answer is -3. If you don't see it, you write it out. 1 minus 4. What happens here? You add the opposite of the second to the first. So this becomes -3. Now you understand why we need to do all that practice with positive and negatives? We're going to be using those a lot. Okay? So, any questions with this? Okay. Now, check this out. Now, the book has been giving you answers that are a little bit different than when you come up with in using the properties. Is that correct? Some of them over 1 or some of them in fraction form. Let me tell you why that happens. Everybody look up, pens down. Check this out. If I was to give you this, 3 to the 2nd over 3 to the 4th. According to the rule that we just found, are they the same base? Yes. What happens to the exponent? Subtract, that's -2. Are we there so far? However, if I was to factor this out, this becomes 3 to the 2nd, which is 3 times 3. This is 3 times 3 times 3 times 3. Are we there so far? So we know that this is a 1 and this is a 1. So let's see. What's left on the numerator? What is 1 times 1? 1. Okay. On the denominator, what is 1 times 1 times 3 times 3? That's 3 to the 2nd, which becomes 1 over 9. You're saying, but didn't I come up with this? Yeah, but can't we write this over 1? Yes, right? It's still the same. So what is the reciprocal of this? 1 over 3 to the 2nd, but we change it to a positive. Why do we do that? Because when we factor out and we use our division properties, this, we have more left over on the denominator. That's why this one ends up in the denominator. Everybody see that? Okay, let's do an example that's going to come up like this. Here he goes. Example 1C and 1D. Copy those, please. All right, let's go over 1C together. Wait a minute. I see a parenthesis here on the denominator. We need to get rid of this parenthesis. What happens when we have exponents outside of a parenthesis? You multiply. So this becomes m to the 10. The n becomes n to the 1. Remember, if it doesn't have an exponent, you add a 1. Okay? We bring these over. N to the 5th, n to the 4th. Are we there so far? Okay, let's use our rule. Let's look at m. 5 minus 10, that's -5. Once again, if you don't see it, you need to write out your exponents. 5 minus 10 becomes 5 plus -10, and that's how we get the -5. Are we there? However, can we have negative exponents? No. From this point forward, since I already explained it earlier, whenever we have a negative exponent, we write it over 1, the reciprocal, and it changes into a positive. Are we there? So therefore, this becomes 1 over m to the 5th. No, it changes to a positive. That's the reason that we write it over 1 and we do the reciprocal. Okay? So now, we're done with the n's. Look at this one. What is n to the 4th and divided by n to the 1st? N to the 3rd. Is this a positive exponent? Yeah, so that one stays where? In the numerator. Does it go to the denominator? No, so we write it here, n to the third. Everybody catch that? Did we go a little bit too fast? Okay, if you don't see it, here we go. Let me show you another way. This became 1 over n to the fifth times, this is n to the third over 1. What is 1 times n to the third? N to the third. What is m to the fifth times 1? M to the fifth. That's how we end up with that. Okay, let's do this one together. Here we go. Look at the 3's. 3 to the first times 2 to the second. And this one is 4 to the negative 3. So since it's a negative, that one goes where? In the denominator, and it changes to a positive. These stay in the numerator. Everybody see that? If I was to ask you to multiply them out, you will multiply them out, but for right now, we'll leave them like that, just so that you can see the property at work. Questions, comments? Is it going pretty fast? Everybody all right? From 1 to 5, how comfortable you are with this property? 1, 5, I got some 4s, 5, 4, 5, 3s, 4, 5, 3s, 4s, okay? We're almost there. So make sure with enough practice for tonight, once again, I'm going to be here after school. Right now I have to go do something right at lunch, but after school I'll be here. So pick this up. Before we leave, last thing. Here you go. Power of quotients. Write this down. Parentheses. 2 to the third. 3 to the fourth. And all that to the fourth power. Okay. Pens down really quick. Let me show you something. If this was to be like that, do we know what to do with this? Yeah, this becomes what? 2 to the 12. However, now we have a denominator, and guess what? We also do that to the exponent on the denominator, so this becomes what? 3 to the 16. See how that applies? Okay, copy that, please. And that's the only thing for the power of quotients. I mean, it's not that big. All it is that you need to remember that you need to multiply the exponent outside times the exponent inside. So, questions, comments? All right, homework. Homework is found on page 420, is that correct? Numbers 25 to 40 odds. All right. Now, guys, once again, if you have any questions, be here for after school tutoring. I'm going to go over the homework. Okay, and last night's homework, turn it in the way out on that inbox over there, number 4. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.